Alright, so in this video, we're going to go over something called tangents and normals. So tangents and normals. And first of all, we need to look at one form for the equation of a line. So you must be familiar with y is equal to mx plus c. Right? We're going to look at an alternate version of writing the equation of a straight line. And that version comes from the definition of a slope. So the slope is the change in y with respect to change in x, right? So suppose you know one point on a graph. So you know the point x1, y1, right? So you can take any point y. So you fix y minus y1 over x minus x1. So you're going to express it like this. So change in y is actually y2 minus y1 over x2 minus x1. But we're going to assume that x and y are variables and we take this point. This is a point on the graph. This is a point on the graph. All right. So now we have this expression. And now what I can do is I can multiply both sides, right? So m is y minus y1 over x minus x1. I can multiply both sides by x minus x1. So I will get y minus y1 is equal to m x minus x1. And this is the form that we are going to use throughout this topic. And I believe I've introduced this form before in one of the chapters. But this is the form that we are going to be using consistently in this topic. So this is the very important formula that you want to know for this chapter. Now let's look at something. So if I have a graph, suppose I have this curve, something like this, the blue curve. On y-axis, I have my x-axis. So the tangent at the point x, right? So let's say this blue dot is the point x1, y1 on this blue curve. The tangent line will just touch the graph at this point, right? So the tangent line is going to look something like this. Okay, that is a very bad tangent line. Okay, something like this maybe. Okay, so this purple line, this is the tangent line. And this is the tangent line at the point x1, y1. That means that it only touches the blue curve at this point, right? So that is the tangent line. So how do we find the equation of this tangent line? Well, we can find the slope of the tangent line. The slope of the tangent line is going to be dy by dx, and I will evaluate it at x is equal to x1, right? So that is going to be my m. So we know that the gradient, the slope of this tangent line, the gradient of the tangent line is given by dy by dx, and we need to find it at this particular point, x1, y1. So I will substitute x1 in here. And there, after I do this, I will use y minus y1. I will take this y1 is equal to m x minus x1. And I will just use this form to get the equation of the tangent line. So what is the normal line? So the line normal to this point will look something like this. So it will look something like this. I think this is a very bad normal line. Okay, let me erase it. Something like this. So the normal line will intersect the tangent line at 90 degrees. It will also pass through the point x1, y1. So we know that if these two straight lines are perpendicular to each other, then they must satisfy that the slope of the first line, right, which is m1 times m2, the product of their slopes must be -1. So the slope of the tangent line times the slope of the normal line, t for tangent and for normal, should be equal to -1. So the slope of the normal line is -1 over the slope of the tangent line, right? So now that we know this, the equation of the normal line, because it passes through y1 and x1 again, we have y minus y1, but this was the slope of the tangent line. The slope of the normal line is going to be 1 minus 1. So it's going to be the slope of the normal line, x minus x1, right? And we know that the slope of the normal line is just given by 1 over the slope of the tangent line, x minus x1. All right. So now that we have all the concepts necessary for this topic, we can start to do some questions. And I won't be solving all the questions because there are so many of them. So we'll just skip some as we go. All right. So I hope you have taken a note of all the ideas here. So if you get the concept, it's not really necessary to memorize the formula, but I hope as we do more questions, you will be getting more familiar with how to approach these types of questions. All right. So this is topic 5E, I believe. Okay, so let me erase the stuff here. I hope that is okay. And we are going to start with this tangents and normals topic. All right. So for question 1, I'm going to do A and C. For question 2, I'm going to do B and D. All right. So question 1 asks me to find the equation of the tangent to each curve at the given point. So my first curve is y is equal to x squared minus 3x plus 2 at the point 3, 2, right? Okay, so this, remember, is going to be your x1. This is going to be your y1. Now we need to find m. So find dy by dx. dy by dx is going to be 2x minus 3, right? If you differentiate this, you're going to get 2x minus 3. Now we want to find dy by dx. We want to evaluate it at x is equal to x1. So 2x1 minus 3. And what is x1? x1 is 3. And that is going to give you 3. So now, remember, y minus y1 for the tangent line is y minus y1 times m of the tangent line, x minus x1. Alright, so y minus y1 is 2, slope of the tangent line is 3, x minus x1 is 3. And now you can simplify. You get 3x minus 9, and y is going to be 3x minus 7. And that is your solution to A. Let's do C. C is the curve 2 minus x cubed x plus 1 to the power 4. So this is a product, right? So we are going to use the product rule. So u, let's say, is 2 minus x cubed. Du by dx is going to be, you bring 3 to the front, 2 minus x squared, but ani x tega, ani x made. So you have to differentiate 2 minus x again. And when you differentiate this, you are going to get a negative 1 from this factor. So you get negative 3, 2 minus x squared. That is going to be your solution. You're going to get a negative 1 from here. And v is x plus 1 to the power 4 dv by dx is equal to 4 x plus 1 cubed, but ani x dega, ani x made. So you have to differentiate x plus 1, but when you do so, you're just going to get positive 1. So you have this. U dv by dx, v du by dx. So the solution for the product rule, right, dy by dx is u dv by dx plus v du by dx. So it's going to be u is just 2 minus x cubed, dv by dx is 4x plus 1 cubed, minus, because we have a minus sign here, v is x plus 1, 4. I copied this minus sign, by the way, and we have 2x, we have 3, 2 minus x squared. So if you substitute values in, you're going to get this expression. And now we want to find dy by dx at x is equal to x1. And now let's look at the point. They said point 1, 16, at 1, 16. So remember, 16 is your y1, 1 is your x1. So let's just substitute 1 into this expression. 2 minus 1 is 1 cubed times 4. 1 plus 1 is 2 cubed minus 3. X, if you substitute 1 here, you get 2 to the power 4. You get 1 to the power 2. So that is going to give you 8 4s is 32, right? This is going to give you 8. 8 4s is 32 minus, this is 16. And 16 3s are 48. So that gives me, I believe, negative 16. Alright. So now, the equation of the tangent line is y minus y1 equal to empty x minus x1. Right? Slope of the tangent. So y minus y1 is 16. Slope of the tangent line is negative 16. And x minus x1 is just x minus x1 was 1, right? And if I simplify, I get the expression minus 16x plus 16. And if I add 16 on both sides, I am going to get this expression. And the textbook just presents it as 16x plus y is 32. Both of these are correct. So we are done with question 1. We did A and C. All right. So find the equation of the normal to each curve at the given point. So let me erase this. We have question B. So y is equal to 3 divided by x plus 1 cube root. So I'm going to write it as 1 over 3 at the point minus 2 comma minus 3. All right. So we want to find dy by dx. So that is going to be 3 d by dx of 1 over x plus 1 to the power 1 over 3, right? So that is going to be 3 d by dx of x plus 1 to the power minus 1 over 3. And now we can differentiate this, right? 3 times bring minus 1 over 3 to the front, x plus 1. And if you subtract 1 from this power, if you do minus 1, you're going to get minus 4 over 3. And any x dega, any x mother. So you have to differentiate x plus 1 again. But when you do so, you are just going to get positive 1. So times 1 is going to give you the same value. So overall, your expression is negative 1 over x plus 1 to the power 4 over 3. And now we are given x1 to be minus 2. So I just evaluate this at x is equal to minus 2. So the slope of the tangent line, remember, when you do dy by dx and you put in a value of x, you're getting the slope of the tangent line. Slope of the tangent line is going to be minus 2 plus 1 is going to be, let's think, minus 2 plus 1 is minus 1. Cube root of minus 1 is minus 1, right? So I have minus 1 to the power 4 over 3. And that is, I believe, going to give you positive 1, I think. Your denominator should be positive. Minus 1 to the power 4 over 3 should be a positive value. Yep. Why? Because you take the cube root of 1. You do 1 over 3 first, and then you do it 4. So this is negative 1. Negative 1 to the power 4 is going to be positive 1. So overall, your answer is just negative 1, right? Because you still have a minus 1 here. So your denominator is positive 1, and you get negative 1 to be the slope of your tangent line. Now, the slope of your normal line times the slope of your tangent line should be equal to negative 1. So your slope of the slope of the normal line should be negative 1 divided by the slope of your tangent line. So you substitute mt to be negative 1, you get slope of your normal line to be positive 1. And everything else is the same. Y minus y1, slope of the normal line, x minus x1. Because question 2 asks you for the equation of the normal line to each curve at the given point. So you have y plus 3, if I substitute minus 3 here, and slope of my normal line was 1, x plus 2, if I substitute minus 2 here. And you will see that y plus 3 is x plus 2, and therefore y is equal to x minus 1. That is your solution. And we are done with B. Alright, so let's do question D. Let me erase this. So question D, we have y is equal to x squared plus 1 divided by square root of x plus 2 at the point minus 1 comma 2. So dy by dx. So this is what we are going to use the quotient rule. So u is my numerator, x squared plus 1. Du by dx is just 2x. V is my denominator. dv by dx is going to give you 1 over 2 square root of x plus 2. Now, I leave you to differentiate it on your own. So your solution, dy by dx, and v squared is just x plus 2. It's going to be v squared, v, du by dx minus u, dv by dx, right? So if you substitute everything, you're going to get this expression. And I am skipping some steps so that you can practice on how to simplify these expressions on your own. So now I need to make a common denominator, right? So if I try to make a common denominator, I am going to get this expression. So I know I did this very, very quickly, but I'll leave you to figure out how you can simplify from this expression to this expression on your own. So the numerator is going to simplify to 3x squared, right? 4x squared minus x squared is 3x squared. 8x minus, so plus 8x minus 1. That is my numerator. My denominator is this expression. So let me just quickly show you how I got there. I have my numerator is equal to 2x square root of x plus 2 minus x squared plus 1 divided by 2 square root of x plus 2. This is what I have here in the numerator, right? So now I will multiply by this denominator here times 2 square root of x plus 2. And I will divide by this denominator here. And think about it. This and this will cancel out, leaving me what I had initially, right? And this allows me to have a common denominator. And now if I simplify my numerator, I'm going to get 4x x plus 2 minus x squared plus 1. And my denominator is 2x plus 2. And this is just my numerator, right? So when you divide it by this expression, that's going to lead to this expression. All right. That is the simplification that I did. Now I need to substitute x is equal to -1, right? I need to find it at -1. And that is going to give me the slope of the tangent line. dy by dx at a particular value of x is always the slope of the tangent line. So slope of the tangent line is going to be 3 minus 8 minus 1 divided by 2 minus 1 to the power 3 over 2. Sorry, 1 to the power. Because you can't have minus 1 to the power 3 over 2. Okay, 1 to the power 3 over 2, that is just 1. So 3 minus 9 is minus 6 over 2, that is minus 3, I believe. I think so, yeah, minus 3. So slope of your normal line is minus 1 over the slope of your tangent line, right? So if you substitute this, minus 3, you're going to get 1 over 3. That is your slope of the normal line. So now, everything else is just the routine procedure. Y minus y1 is going to be m of the normal line x minus x1. That is going to give you the equation of the normal line. If it's the tangent, if you want the equation of the tangent line, you just find mt. So y minus 2, y1 is 2. Slope of the normal line is 1 over 3, right? 1 over 3, x plus 1. So if you substitute this in, so if I multiply by 3 on both sides, I'm going to get 3y minus 6 is x plus 1. And 3y minus x is equal to 7. So that is going to be your equation. The textbook likes to write it as 3y is equal to x plus 7. It's the same thing. All right. So I hope this was clear. And we are done with question 2. Okay. Question 3. A curve passes through this point and has the equation this. So we want to find the equation of the tangent and equation of the normal. All right. So y is equal to 8x plus 2 squared. Y is equal to 8 divided by x plus 2 squared at the point 2 comma half, I believe. Yes, this is point A. So now let's find dy by dx. So dy by dx is 8. I can factor this 8 out, right? Remember, d by dx of k f of x is k d by dx of f of x, right? So this is the rule that we're using here. So d by dx of 1 over x squared. All right. So 8, that is d by dx of x plus 2 to the power minus 2. And now we can use the power rule. So 8, you bring minus 2 to the front. X plus 2 minus 2 minus 1 going to give you minus 3 times ani x tega, ani x madi. This was x plus 2. So you differentiate it, you are going to get a 1 here. So times 1 is just, you don't have to write it out because anything times 1 is that thing itself, right? So you are going to get minus 16 divided by x plus 2 d cubed. All right. So now that we have this, let's find the slope of the tangent line. Slope of the tangent line is dy by dx times at x is equal to 2. That is the a value, x1 value that we are given. So minus 16 divided by 4 cubed, right? If I substitute 2 here, I'm going to get 4 cubed. So 4 cubed is 64. So that gives you minus 1 over 4. And mn is just minus 1 over mt. That is going to be minus 1 over 4. And that is going to give me 4. So y minus y1 is equal to mx minus mt x minus x1. So that is going to be the slope equation of your tangent line. And this equation of your normal line is going to be this. So y minus y1 is half, remember, 2 comma half. And you have minus 1 over 4, x minus 2. And if you simplify this, you multiply by 4 on both sides, you get this expression, I believe. So I leave you to simplify this expression on your own. But overall, I believe you should be getting this. When you simplify, you're going to get, if you add x on both sides, you get 4y plus x. If you add 2 on both sides, you get 4. So that is the equation of your tangent line. And the equation of your normal line is going to be y minus half. Mn is 4, x minus 2, right? This is 4. We calculate it to be 4 here. So if you multiply by 2 on both sides, you have 2y minus 1, 8x minus 16. And I'm doing this very quickly, so hopefully you can practice simplifying this on your own. So that is going to be, let me think about it. So you have 2y minus 8x is negative 15, I think. Yeah, if you add 1 on both sides and you subtract 8x. If you divide by 2, you are going to get this expression. Yeah, that is, so this is the correct answer. So this is the one that the textbook has. If you add 4x on both sides, then you get y is equal to 4x minus 7.5. But this is your correct answer. All right, so we're done with 3. It's the same routine procedure, actually, to solve these questions. All right. So we are done with question 4. I hope that was clear. I know I'm doing things a bit quickly, but I think you can catch up now that we have done so many, almost hundreds and hundreds of questions in this playlist. So yeah. So question 4, the equation of this curve is given. So y is equal to 5 minus 3x minus 2x squared. So y is equal to 5 minus 3x minus 2x squared, right? And now we can find dy by, so first question says, show that the equation of the normal at this point. So we want to find equation of the normal at minus 2 comma 3. So let's just find that equation. So first take the derivative, and you are going to get this expression. So I'm not going to differentiate it very slowly. I think you can catch up on your own now because we have done so many derivative questions. So you're going to get minus 3 minus 4x, and I encourage you to try it a bit slowly. Here's how my thought process works. Derivative of 5 is 0. I don't need to write it down. Derivative of minus 3x is minus 3. Derivative of minus 2x squared is going to give me minus 4x, right? You keep your minus 2, and then you bring this 2 down. So minus 2 times 2 is minus 4, and then you have 1 here. So this is how I got this expression. So I encourage you to use the formula, use the things that you have also learned in class. And now I need to find dy by dx when x is equal to negative 2. So negative 3 minus 4 times minus 2. So negative 3 plus 4 2s are 8, right? So you're going to get positive 5. But remember, this is mt is 5. Mn is going to be negative 1 over mt, right? Slope of your normal line is negative 1 over your slope of the tangent line, so negative 1 over 5. So now you just find the equation of your normal line. Mn x minus 6. So y minus 3 minus 1 over 5, x plus 2. If you substitute x1 and y1 in, you're going to get this expression. If I multiply by 5 on both sides, I'm going to get 5y minus 15 minus x minus 2. And I'm going to get 5y plus x is equal to 13. And that is, I think, exactly what they want us to show, right? Yeah. 5y plus x is 13. So we are done. Find the coordinates of the point at which the normal meets the curve again. So this is the normal line. We want it to meet the curve again. All right. So basically, we are going to be solving a quadratic equation. From this expression, we know that y is 13 minus x over 5, right? So now I'll just substitute y here. 13 minus x over 5. I want to solve it when these 2 points are equal. So 5 minus 3x minus 2x squared. If I multiply by 5 on both sides, I'm going to get 25 minus 15x minus 10x squared. So this is the normal line This is my curve. I want to find the points where they are equal again. So I'm going to equate the values of y. All right. So now I need to solve this quadratic equation. I think we can simplify this a bit further. So if I bring everything here on this side, I am going to get 14x minus 12 is equal to 0, I believe. I think this is what everything is going to simplify to. And I can divide by 2. So I'm going to get 5x squared plus 7x minus 6 is equal to 0. So now, can I factorize this? Something that has a sum of 7 and a product of 30. That is negative 30, right? Sum 7 and product of negative 30. Oh, yeah, I can factorize this. So you need something that gives you a sum of positive 7 and a product of negative 30, right? Negative 6, 5, so 30. So what are those two numbers? Well, that is going to be positive 10 and negative 3. If you add them together, you're going to get 7. And if you multiply them together, you're going to get that. So now 5x squared plus 10x minus 3x minus 6 gives me 0. So now I can factor out a 5x from my first two terms. So I'm going to get x plus 2. You factor out a negative 3 from these two terms, you're going to get x plus 2 again. So you factor out x plus 2, and you are left with this expression. So x negative 2 was given. We know that it already meets at this point, negative 2 comma 3. So we need to solve for the other part. We get x negative 2, but this is already given. We need to solve for this. So 5x is equal to 3, right, from this expression. So x is equal to 3 over 5. And if you substitute x is equal to 3 over 5 here, 5y plus 3 over 5 is 13. 5y is going to be, so 13 is just 65 over 5 minus 3 over 5. So 5y is 62 over 5. Y is 62 over 25. And therefore, your coordinates of the point at which the normal meets the curve again is 3 over 5, 62 over 25. All right. So 3 over 5 is just 0.6. 62 over 25 is going to give you 2.48. So that is going to be your solution. But this is good enough. 3 over 5 and 62 over 25. We're done with question 4. All right, tiring. The normal to the curve at this point intersects the y-axis at point P. So very simple, right? You write your equation, x cubed minus 5x plus 3. At what point? Minus 1 comma 7. So you find dy by dx, and that is going to give you 3x squared minus 5, right? And then you substitute x is equal to x1, which is equal to negative 1. So 3 times negative 1 squared minus 5 is just 3 minus 5, and that is minus 2. So that is mt is equal to negative 2. We are concerned with the normal line. So mn is minus 1 over mt. So that is going to give me 1 over 2 if you substitute this here. So now y minus y1, mn x minus x1 is going to give me the equation of the normal line. So 1 minus 7, y1 is 7, mn is positive half, x minus of minus 1. So x plus 1. So now 2y minus 14 is equal to x plus 1. 2y minus x is going to be 15. So that is the equation of my normal line here. So normal to the curve, so we know that normal intersects the y-axis at point P. So if it says intersects the y-axis, that means x is going to be 0, right? If you have a coordinate axis, if it's intersecting the y-axis, x is going to be 0. So you substitute x is 0 here, and you get 2y is 15. Y is going to be 15 by 2. So therefore, the coordinates are 0, 7.5, or 15 by 2. And we are done. Question 6. The tangents to the curve meet at the point Q. Okay, so basically you have y is equal to 5 minus 3x minus x squared, right? So first of all, consider point P, minus 1 comma 7. dy by dx is going to be equal to minus 3 minus 2x, right? So if you differentiate this, you are going to get this expression, and I'm going to leave the differentiation to you. So you substitute x is equal to negative 1 here. If you do so, you are going to get minus 1. So therefore, if you are asked to find the equation of the tangent line, you know that that is y minus y1 mt x minus x1, where mt is the slope of the tangent line. So you substitute these values, right? So y minus 7, mt is minus 1, x plus 1. If you substitute negative 1 comma 7 here, you are going to get this equation. So you get minus x minus 1. If you simplify, you get y is equal to minus x plus 6. That is the equation of the tangent at minus 1 comma 7. Now we have another point. We need to find the equation of the tangent here as well. So we know dy by dx, we already have the expression, is minus 3 minus 2x. We need to evaluate this at x is equal to minus 4 as well. This is our second point. So minus 3 minus 2 at minus 4, that is going to give you positive 5, I think. So therefore, the equation of the tangent line is going to be y minus y1 m tangent x minus x1, right? So now I substitute. So this point was minus 4 comma 1, right? So I substitute these values here. So y minus 1 mt is 5x plus 4, and I'm gonna get y minus 1 is equal to 5x plus 20, and y is gonna be 5x plus 21. All right, so now I know the equation of my two tangent lines. I can equate these because we want to find where do the tangent lines intersect, right? So 5x plus 21 is going to be minus x plus 6. 6x, if I simplify everything, is going to be negative 15, I believe. And x is going to be negative 15 by 6. So 5 times 3, 3 times 2. So that is going to give me negative 2.5 or negative 5 by 2. All right, and if I substitute negative 5 by 2 here, any equation, any tangent equation is fine. Because the intersection point is going to be on both lines, right? So you can substitute this x anywhere. So you have 25 over 2 plus 21. So 21 is just 42 over 2. And eventually, this thing is going to simplify to 17 over 2. So therefore, the Q point is going to have the coordinates negative 2.5 here, and y is 17 over 2. So that is 8.5. That is going to be your solution to 6. All right, quite a lengthy question. But this is your solution, negative 2.5 and 8.5. All right, probably there will be a part 2 to this video because there are so many questions. Oh my god. Okay. So the normal to this curve at this point meets the x-axis. Okay, so basically equation of the normal. We want to find the equation of the normal. I think 7 only has 2 parts as well. Okay, so y is going to be 4 minus 2 square root of x. Find dy by dx is d by dx of 4 minus 2 square root of x, right? And derivative of 4 is just 0. So I can separate this as like this, right? So keep the sign. So remember, d by dx of f of x plus or minus g of x, you can just do it individually. And you preserve the sign, whatever is in between. Plus or minus d by dx of g of x. So this was introduced in the first video, although I think I wrote only plus, but it works for minus as well. Subtraction is just addition with a negative number, right? So d by dx of 4 is 0 minus 2d by dx of square root of x. And remember, d by dx of square root of x is 1 over 2 square root of x. So this cancels out, so I get negative 1 over square root of x. So that is my solution here at this point. So I need to substitute x is equal to 16. So we have 16 comma negative 4, right? Right. So I substitute x is equal to 16. I am going to get negative 1 over 4 here. But remember, this is mt. We are concerned with the normal line. So minus 1 over mt. And that is going to give you positive 4 if you substitute this here. So now I know the slope of the normal line. The equation of the normal line is just going to be mn x minus x1, right? So y minus y1 minus of minus 4 is going to give me plus 4. Slope of n is 4x minus 16. So that is going to give me 4x minus 64. Y is equal to 4x minus 68. All right. So we are done with A, and it says find the meets the x-axis at coordinates q. So if it's meeting the x-axis, something like this, remember y is equal to 0 here. So I need to substitute y0. So if I substitute y is equal to 0, I get 0 is 4x minus 68. 68 is equal to 4x, and x is going to be 68 divided by 4. That is going to be 27. Therefore, you have 27 comma 0. That is going to be the coordinates. Sorry, 17, not 27. 17 comma 0. 68 divided by 4 is 17. All right. So we're done with 7. Okay, question 8. The equation of the curve is this. Actually, this is very, very similar to the question that we have done. So I'm not sure if I want to do it again or not. Okay, let's just do it. Whatever. Y is 2x minus 10 over x squared plus 8. dy by dx is going to be 2. Right? If you differentiate this, you get 2. If you differentiate this, you're going to get 0. So I'll ignore it. Minus 10. And then I have to differentiate x to the power minus 2. Right? So I keep the sign. I bring this 10 out and I differentiate 1 over x squared. So I'm going to get 2 minus 10 minus 2 x to the power minus 3. So eventually, my solution is going to be, this is going to be my derivative. So that is dy by dx. Show that the normal to the curve meets the y-axis. Okay, so now we are given this point, right? So I can find mt. Mt is going to be 2 plus 20, and instead of x, I substitute minus 4. Minus 4 cubed. And that is going to be 2 minus, and if you simplify this, you're going to get 20 over 64. And 20 over 64 is 10 over 32. 10 over 32 is 5 over 16. So you have this expression. So 32 over 16 minus 5 over 16. If you simplify, you are going to get 27 over 16. Right? Now remember, we are concerned with the normal line. And the slope of the normal line is given by this expression. So it's going to be, if you substitute this here, you are going to get this expression. Now let's find the equation of the normal line. All right. So now y minus y1. So y plus 5 over 8, because y1 is this expression. And mn is just this ugly expression. So negative 16 over 27. And x minus x1 gives me this. And now I have to simplify this. Okay. It's going to be 16 over 27x minus 64 over 27. All right. Very ugly expression, right? But it says meets the y-axis at this point. So if it's meeting the y-axis, my x is going to be 0. Remember, if it's meeting the y-axis, your x-coordinate is 0 something, right? So now I can substitute x0 here. So I have y plus 5 over 8 is equal to negative 64 over 27. And y is minus 64 over 27 minus 5 over 8. Negative, I factor out the negative. I get this expression. And now I need to simplify. So I'll use the butterfly method. 64 times 8. That gives me 512. 5 times 27. That gives me 135. 8 times 27. 216. So now this is going to be negative. If I add 512 plus 135, I get 647 over 216. And now if I divide, so 216 times 3, so if you use your calculator, 216 times 3 is going to be 648. So this is one less than this. So I know that it's going to be 215 over 216 in my mixed fraction. But you can use your standard method as well. So what would be your standard method to convert this into mixed fraction? Well, you press 647 divided by 216 in your calculator. So if you do so, you get 2.999 something. So you pick your whole number, -2, right? And then you do 647 minus 2, this solution, right? Minus 2 times, so ignore the negative sign. We're just going to convert this into mixed fraction. The negative will just stay there, right? So 2 was my whole number. And what was my denominator? 216. So you want to put this whole number and your numerator. Sorry about that. So we were discussing how to, I think I paused the video. Okay. So we were discussing how to convert this to a mixed fraction. So basically you want to keep your negative sign. You keep your whole number, which is 2. And now what you want to do is you want to take 647 minus 2. So this 2 comes from here, times 216 divided by 216. So minus 647, 2 times 216, that is going to give you 215 over 216. So I did it a bit quickly because I saw the pattern. But here, yeah, that is going to be your solution. Right? So your x is 0, y is -2, 215 over 216. All right.